Hello fellow Tekla user. Today, I am going to present to you on how we were able to use or integrate Tekla Structures 2020 to our project. My name is Marvin and I am a BIM modeler from Huaseng Builder. As a brief introduction about myself, I am a BIM modeler for more than 5 years here in Singapore. I was mostly assigned to infrastructure projects such as land preparation works for airport development, construction of roads and vehicular bridge, drains, earthworks in Punggol and Sengkang, and construction of flyover at TPE. Okay, so this presentation just consists of 3 main parts. First, my company and project description. Next, the main topic for this presentation, sample process on how we use Tekla. Last, just a quick summary or review. About our company, Huaseng Builder or HSB is a leading civil engineering and construction provider. It's been around in the industry since 1992. Our main focus or projects are infrastructures like aircraft pavement, runway, taxiway, highway, expressway, bridges, drainage, earthworks, and etc. HSB is under A1 under BCA classification for civil engineering, and it can tender for projects with no maximum amount limit. Here are some of the awards that HSB had obtained, like the WSH Award, BIS Safe Star, and Green and Gracious. Okay, so we now move about my current project. I am a BIM modeler of this project, RC118, construction of viaduct from TPE to PIE westbound and Upper Changi Road East under LTA, with contract value of $95.6 million. As you can see here in the photo I prepared, we need to construct this whole flyover running across TPE. Aside from the viaduct, there are associated works in the contract like construction of drains and road widening on Upper Changi Road East. So that's for the company and project briefing. Let's move now on how we were able to use Tekla software in our project. Okay, we started training on Tekla last March of 2020 only, before the pandemic and work from home issue. And we did online training session, our questions were all answered by the trainer under Trimble. So I think there is no issue with online training. And about our project BIM, we initially using third-party software called Revit. I'm sure all of you know this software already. We had the Revit model for the project starting from tender stage, and because Revit has been around in the market for a long time and very popular as well for construction companies. So first, before we model, we have to make sure that we follow the BCA approval drawings. An example is shown here. Here you can see the hammerhead, or is a type of crosshead beam that sits on top of column and will support later the precast beams. This hammerhead is quite big, around 12 meters wide and 10 meters long. That is why there is a hollow inside in order to decrease the weight before launching. Because this is a precast element, we want this to be light as possible. And these are two drawings that relates to this hammerhead. You may notice that these are not just dimensions, but with rebar details as well. And this is what we need for our Tekla, because later we have to put the rebar details on this particular hammerhead. Next, we move to modeling the element into Revit. Since we have from start the tender model under Revit, we can just modify this part following the BCA approved drawings. Here you can see the hammerhead, and here you can see the cubes inside the hammerhead, and this is the hollow inside the hammerhead. Okay, Next step is converting this object into IFC from Revit. It is under File, then Export. Usually IFC file size will depend on Revit file size as well. Okay, next is opening the Tekla software. Here is the opening or startup window that should appear if you open your Tekla. Then we create a new project. Typically, this is what will show under new project settings. Now, as I add the model of IFC in Tekla, this window will appear. And I will just locate our IFC file. And in our case, I named it 2P11 Hammerhead. Note that this is the IFC file that we exported from Revit from previous steps. Okay, check if IFC can be imported properly. And here in our example, we can see this IFC file from our Revit. And if you are asking why we did not start from Tekla, yes, we can start, but I just prefer this in our project because we started way back tender using Revit already. So this process is just using or integrating Tekla together with our Revit in our BIM workflow. Okay, so now I am starting the IFC object conversion here at the right side. And this window will appear. Later, I will just convert this object to be able to fully import this Hammerhead into Tekla. You may ask why there is need to use IFC object conversion. It is because I noticed that you cannot model rebar on IFC objects. And by doing this IFC conversion, we are converting this IFC into Tekla native element like this. After conversion, it will become a Tekla element, and so the rebar detailing will be possible. Here you can change the properties once it become a Tekla element, like change the color, all just in your right hand side. Now I will add or model the required rebars, preferring from BCA Approved Drawing, as you see here in this example. And like here, you can see the post tension strand, this long rebar here, and I also put the normal links. This particular example, my manager wants to see how the rebar clashes of this post tension strand to the links. The good thing about Tekla is that it supports many other applications or add-ons or downloadable contents. And this is the publish to 3D PDF. Basically, this will produce a 3D PDF depending on what is the 3D view on Tekla. By the way, a normal PDF can open a 3D PDF, or normal software PDF like Adobe, and it has a same file extension. Okay, so this is the output file of 3D PDF. This is just a snapshot, and this one I want to show the managers and my team if they want to plan ahead, such as avoiding rebar clashes, because they can only see this based on 3D PDF, and because they don't have Revit or Tekla. From this 3D PDF, they can have good discussion about planning or maybe some design variations in order to avoid future problems such as rebar clashes. Here is another example I prepared with rebar. You can see here that these two portals have opposite crossfalls. We need to properly plan how we will place the precast beams in between these two portals. And this is another example of our rebar detailing. Here we can plan ahead because based on model, the slab rebars may not pass through the crosshead starter bars. One solution that they are looking for is to raise the slab and premix so that there will have no rebar clashes. Another possible solution is modifying the rebar sizes and spacing to fit it into crosshead starter bars. All of these were possible because of 3D PDF, possible to visualize, which comes from Tekla structure with rebar detailing model. So, last part of this presentation is just summary and review. Okay, in summary, we are using different software such as AutoCAD for basic drawing, Revit for beam modeling, Navisworks for video presentations, and Tekla structures mostly for rebar detailing, and some other softwares like InfraWorks in order to implement BIM in our project. We had the overall model of the project using Revit, starting from tender. That is why we didn't start with Tekla. Note that this process is just using or integrating Tekla together with our Revit, and we just started the training last March 2020. After finalizing Revit model, which referred to BCA Approved Drawing, we then export it to IFC format or import it to Tekla. Conversion of model to industry foundation classes or IFC is necessary because this format is the neutral format or universal platform for BIM or data modeling, and no vendors own IFC, not Autodesk nor Trimble. And this is a similar way on how PDFs are working. I mean, you can open different software. You can open different software if you want to open the PDF. Then we can proceed rebar detailing for the object using Tekla. Last for summary is to export the file to 3D PDF, which will be used by the project team. Review. Tekla is good for rebar modeling. Our project has many structural elements such as slabs, crossheads, columns, pile caps, piles, beams that are needed to be modeled with rebar. One thing I like in Tekla is that we can copy and paste typical rebar detailings from one column to another, and I find it difficult if I use other software. So rebar modeling, I prefer Tekla. Tekla has many useful outside applications such as post-tensioning and 3D PDF converter. These are the two applications I use so far. All our precast beams have post-tension strands, so the post-tension design is very useful. 3D PDF is for the whole team to see the BIM model. 3D PDF with rebar model is helpful in our project to visualize and to plan on possible variations, like to avoid rebar clashes. Especially we are using mostly precast elements like the hammerhead I shown and all the precast beams. We can plan ahead using our BIM software to see how are the things going to be built and to plan accordingly. Many companies are using Tekla. So far, we have 2 subcontractors that uses Tekla structures. We were able to collaborate with them by exchanging our Tekla files. Overall, Tekla is very helpful to our project. We had better time efficiency in modeling using Tekla, and better cost saving in planning ahead construction using BIM produced by Tekla. That's the end of this presentation. Thank you for your time listening.